Algebra 2, 2.4a, Inequality Solutions on a Number Line. We learned in Algebra 1 that math sentences that contain the symbols less than, greater than, less than or equal to, or greater than or equal to are called inequalities. And a solution of an inequality is any number that makes it true. And the set of all the solutions is the solution set. And when we've found all the solutions of the inequality, then we've solved the inequality. And inequalities have an infinite amount of solutions. If a number is greater than 3, then all numbers greater than 3 are the solution. So if n is greater than 3, well, that includes decimals like 3.1 or 3.01 and even 3.00001, but it doesn't include 3. It's just any number greater than 3. And even with a little tiny piece of a decimal like this, it makes it larger than 3, doesn't it? Well, we can determine if a given number is a solution to an inequality. All we have to do is plug the number in for x and see if it works. Could it be 5? Well, 5 plus 3 is not less than 6, so no, that's false. 5 is not a solution. Could 1 be a solution to this one? Well, we could plug 1 in and do 2 times 1 minus 3 is greater than negative 3. On this side of the inequality, we've got 2 minus 3, that's a negative 1, and negative 1 is greater than negative 3, and that's true. So yes, 1 can be a solution for that inequality. How about this one? Can 3 be a solution? We plug 3 in for x wherever we see it. We get 4 times 3 is 12 minus 1, that's an 11. 3 times 3 is 9, plus 2 is 11. 11 is less than or equal to 11? Yeah, it's equal to it. So yes, 3 could be a solution. Well, when we graph these on a number line, we use a filled-in dot to show that the number is included or an open dot to show it's not included. If we use interval notation, we use brackets to show it's included or parentheses to show it's not included. So for x is less than 3, 3 is not included because x is less than it. So we use an open circle to show it's not included, and we draw our interval going all the way into the negative infinity direction. And the solution includes all the numbers that are less than 3 but not 3. The numbers that are less than 3 are included in this interval right here. That's the interval. That's the solution on the number line. And we can write the solution in set builder notation as x such that x is less than 3. We can also write it in interval notation as a parentheses with the arrow going in that direction to show our interval. And we would write it with a parentheses on this side with the 3 and a parentheses with negative infinity on this side, showing that that's our solution. When writing solutions in interval notation, the smaller numbers are on the left and the larger numbers are on the right. So that means 2 is not included, but 3 is, and the solution is all the numbers in between there. We always use a parentheses next to an infinity symbol, whether it's negative or positive, but never a bracket. And if we see or equal to, we know right away that we're going to use a bracket because if it's equal to it, it includes it, and that would also be a filled-in dot, wouldn't it? Now, there's no such number as negative infinity, but we use this to show that it's going on forever into the negatives. See? X is greater than or equal to a negative 2. Well, it could be equal to it, so we're going to include it by putting in a dot, a filled-in dot. And our interval is going to continue on going bigger and bigger because x is larger than a negative 2. In set builder notation, it's x such that x is greater than or equal to a negative 2. In interval notation, because the negative 2 could be equal to x, we've included it with a bracket, and we're going to the right with our arrow to show that it's included, and we've got a parentheses next to our infinity because that's the rule. And in interval notation, you can see how quickly you can look at a graph and look at the interval notation and see what's going on. The bracket means it's included. We know negative 2 is included, and it goes on into infinity. See? By looking at this in interval notation, we can see 3 is not included, and it goes into negative infinity. That's where it differs for the open and closed dot, because they're graphed differently than they're written as a solution. See? So our next video, we're going to go into more detail in 2.4b about interval notation and set builder notation. We're going to talk about open and closed and half open notation. And if you go to this description, you'll see the link to the Algebra 2 playlist. There's several videos in there. There's more than 30 now. And you can do a review for a chapter test. You can click on that link if you want to do a midterm review and study, or if you have finals coming up. But that's kind of early because we're only in chapter 2. So I hope this was helpful. And if you want to know more about set builder notation and interval notation, watch the next video. All right? Bye.